Hi everyone. Today, we're going to talk about equilibrium. A system is said to be at complete equilibrium if it has reached mechanical, phase, thermal and chemical equilibrium. Here are brief ideas about what these equilibria are all about. Firstly, thermal equilibrium is an equilibrium where the temperature is the same throughout the entire system. Secondly, phase equilibrium is where the mass of each phase reaches an equilibrium level and stays there. Thirdly, there is no change in pressure at any point in the system with time when mechanical equilibrium is achieved. Lastly, chemical equilibrium is a condition where the composition does not change with time. Thermal equilibrium. When a hot object is placed in thermal contact with a cold object, heat flows from the warmer to a cooler object. This continues until they are in thermal equilibrium. Both of the objects will have the same temperature. Here comes the 0th law of thermodynamics. If A and B are in thermal equilibrium and B and C are in thermal equilibrium, therefore A, B, and C are all at the same temperature.
Next, phase equilibrium. First of all, phase is a homogeneous portion of a system that has uniform physical and chemical characteristics. It is a physically distinct from other phases, chemically homogeneous and mechanically separable portion of a system. Thus, phase equilibrium is the study of equilibrium which exists within states of matter. One will need to know what is phase diagram. It includes two external variables, namely temperature and pressure, along with internal variables such as number of phases, high number of chemical species. N among these gives the degree of freedom, F. This brings us to the Gibbs phase rule, which F equals to 2 minus pi plus N. Moreover, a phase diagram is a diagram that depicts the existence of different phases of a system. It represents the relationships between temperature and the compositions and the quantities of phases at equilibrium.
The following equilibrium is mechanical equilibrium. Whenever the net force on an object is zero, the object is in mechanical equilibrium. This object will continue in that condition indefinitely unless acted upon an external force. This is known as equilibrium rule. An object at rest can also be known as static equilibrium. In this case, the pushing force acting on that object is equal to the friction force but in the opposite direction. On the other hand, an object moving at constant velocity is said to be in dynamic equilibrium. Finally, chemical equilibrium. Chemical equilibrium is the state in which the rate of forward reaction equals the rate of backward reaction. The rate of reaction can be represented by the following equation. The graph on the right is a graph of rate of reaction against time. We can see that chemical equilibrium is achieved when the rate of reaction of both forward and reverse reaction are the same.